Hi there, welcome back to factoring. We've talked about the difference of two perfect squares. We've talked about factoring some trinomials by using guess and check or ACbox/MARF. We'll also talk today about factoring polynomials with four terms, factor by grouping. Okay, this is if you've got four terms. Okay, and so an example of factoring by grouping, I can show you. Okay. And here it is. If you want to factor by grouping, there'll be four terms, and you first look to see, is there a GCF? Okay, look at this. Is there a greatest common factor that will go into all four terms? If it only just goes into three of them, it doesn't count. Okay, is there a greatest common factor you can pull to all of them? And if you look at each of these ones right here, you'll notice no GCF comes out of all these four terms. There isn't one out of these. But this one you can take out a 2. Okay, so on this one, before you would do anything, you would take out a factor of a 2, and you're left with 6x cubed minus 16x squared plus 3x, and then minus 8. Okay, after that, you would keep on doing factor by grouping. We'll talk about that. We'll come back to this problem in a moment. Let's go over here. Factor by grouping. Is there a GCF overall? If not, then what you're going to do is you're going to break it into half. Look at the first two items, and we're going to take out the greatest common factor of both of those. We're going to take out 3x squared. You're left with 5x minus 4. And the GCF of the third and fourth terms would be a positive 2. Okay, if the third term is negative, you've got to take out a negative. So take out a 2, you're left with 5x minus 4. If you've done things correctly and it factors by grouping, both these binomials will match up. So in the first group and the second group, you notice you have a common binomial of 5x minus 4. And when you take those out, the remaining items would be 3x squared plus 2. Okay, so you take out 5x minus 4, and your remaining item is going to be 3x squared plus 2. Okay, so factoring by grouping, when you're done with that, you can look and see, do either of these binomials go further? Okay, and so neither of these will go further, so we're set. Let's go back to this problem over here. 2 will be on our final answer, and you know we're going to have two binomials. So let's look at this. Is there a greatest common factor of these first two terms? And the greatest common factor is going to be 2x squared. And what remains is going to be 3x minus 8. And you've got to take out something, take out a 1, you get 3x minus 8. And the binomial that's in common is going to be 3x minus 8. And what remains when you're done is 2x squared plus 1. And so that's going to be your answer. Now, let's look at this previous one. If you look at this previous one, there is no greatest common factor that goes into all three. If you look at the greatest common factor of the first two, you can take out a 9x squared. You're left with 3x plus 5. Of these third and fourth, again, if the third term's negative, you've got to take out a negative. So you're going to take out a negative 4. You're left with 3x plus 5. Now, I want you to look and see what we've got going on. 3x plus 5 is the binomial in common. What remains is 9x squared minus 4. Now, one of these is going to go further because it's the difference of two perfect squares. Difference means that they're going to be subtraction between them. Perfect squares means that both of them are perfect squares. 9x squared is a perfect square because 3x times 3x makes that. 4 is also a perfect square because 2 times 2 gives that as well. So this right here actually goes one step further. It's going to be 3x plus 2 and 3x minus 2. The product of those two gives you back to the original problem. So your answer is going to be as shown. Okay, on the worksheet that I assigned today, there are a couple things that are a little bit trickier, okay? And so I want you guys to see when you get to the back side, you'll notice that there are some items that are x to the fourth minus 16 and this type of thing as well. I think what you need to do is check to see, do you have a clue what they're asking? They want you to put it in standard form, which means put it in order. Okay, so 33 you'll have to rearrange. Put it as 16x squared plus 40x plus 25. Then you can go ahead and factor that. On these previous ones, you're going to have to watch to see, do you know what times what will give you x to the fourth. And here's a hint. When you multiply those, x squared times x squared, remember you add their exponents. So it'd be x to the fourth. If your problem said something like this, x to the sixth, say minus 16, it'd be x to the third times x to the third, because when you multiply these items, you're going to add their exponents to get back to the original problem. So just to note to yourself on those items. Think about this as well. If you've got x to the 2n, what plus what gives us 2n? Just a thought. Okay, so if you add them up, you're going to get 2n. That is just a hint for you guys today.